This last example of looking at limits graphically involves a kind of interesting function. We're going to take the sine of 1 divided by x. So we know that when x is 0, that is when we try to divide by 0, we're not going to be able to evaluate the sign. 1 divided by 0 is undefined. How do you take the sign of undefined? Well, we can't. But it's kind of an interesting function the way it behaves close to 0. So let's take a look. I'm going to graph this. And it doesn't do an awful lot when we're far away. This is a window that goes from -10 to +10 on the x-axis and from -5 to +5 on the y-axis. And as we see, it looks pretty smooth. There's not much happening as we're away from x equal to 0. But as we get closer to x equal to 0, less than 1 away from either side, it looks like something more interesting might be happening. So let's change our window so we can kind of zoom in there. And we'll change that x min to -1, and we'll change our x max to +1. So we'll really kind of narrow our viewing window here. And we'll graph it again. And it looks pretty good, again, away from the center of the graph, away from x equal to 0. But the closer we are to 0 there, the weirder it starts to look. So let's zoom that window in again. And let's maybe we go from -0.25 to +0.25. We'll graph that. And we get kind of the same picture. It seems like every time we zoom in, we see kind of the same picture. Things seem pretty good and pretty nice and smooth away, but as we get closer and closer and closer to 0, things look kind of strange and weird. So let's do the same thing. Let's take our window. Let's maybe add a 0 to these things here. So let's go to maybe -0.025. And let's go to +0.025. So we're making this a really narrow window. And we'll graph again. Now things don't look quite as smooth to either side. And they look really kind of weird in the middle. Basically what the calculator is doing is it's having trouble graphing everything in the middle. Things are beginning to happen so fast and so quickly that it can't graph things very accurately because it only has so much resolution in terms of the number of pixels that it can use to represent graphs. But essentially what we're seeing here is a function that just keeps going back and forth between -1 and +1, -1 and +1. And the closer that we get to x equal to 0, the faster that it's making those changes. In other words, the period of the sine function is different all the time. And it's getting smaller and smaller and smaller, so that as we get closer and closer and closer to x equal to 0, the period is also getting closer and closer and closer to 0. But more importantly, the values of the functions are always slipping back and forth between -1 and +1. That is, the function never approaches any specific number from the left or any specific number from the right. This is known as oscillating behavior, and it's something that we really won't see as we go through this section, but it's something that you should be aware of because it's another mode that limits have for failing to exist.